What if every volcano in the Ring of Fire erupted at the same time? 1,000 volcanoes, billions of tons of ash, oceans in revolt. The Ring of Fire, Earth's most dangerous fault line, stretches over 40,000 kilometers, wrapping around the Pacific like a fiery crown. It's the birthplace of megathrust earthquakes, supervolcanoes, and devastating tsunamis. But beneath this seemingly quiet boundary lies something even more terrifying force that could, in theory, change life on Earth forever. In this video, we explore the science, history, and future of Earth's greatest natural threat. The Ring of Fire isn't a single fault or volcano. It's a massive geological system circling the Pacific Ocean. It touches the coast of the Americas, Asia, and Oceania, linking Chile, California, Alaska, Japan, the Philippines, Papua New Guinea, and New Zealand. Here, tectonic plates, giant slabs of Earth's crust, are constantly in motion. Some collide, others grind past one another, but the most violent motion is subduction, where one plate dives beneath another, melting into magma deep underground. This creates subduction zones, regions of extreme heat and pressure. Above them rise volcanic arcs, chains of volcanoes born from the rising magma. And stretching along the edges of the Pacific lie ocean trenches, deep scars where the crust is being consumed. With all this fire and fury beneath the surface, could it all erupt at once? Short answer, not likely. Long answer, it's complicated and far more frightening. Each volcano along the Ring of Fire has its own magma chamber, its own pressure buildup, and its own eruption timeline. They're separate, but they're not isolated, because when one system erupts or fractures, it can shift stress along nearby faults. Seismic events influence one another. Like a chain of dominoes, not all fall, but enough to cause chaos. Recent studies, USGS, Nature Geoscience, have shown major eruptions can trigger nearby activity. Some clusters of eruptions occurred within decades or even years, but a global scale chain reaction never recorded yet. Let's imagine the impossible. In a moment of geological madness, dozens of major volcanoes begin erupting across the Pacific. Tsunamis crash into the coasts. Ash clouds blot out the sun. Air travel halts. Crops fail. Oceans rise. What began as science becomes survival. Historical warnings from the Ring of Fire. In 1815, Mount Tambora exploded with such force that it darkened skies from Indonesia to Europe. The following year was known as the Year Without a Summer. Crops failed across the Northern Hemisphere. Famine spread, civil unrest followed. In 1883, Krakatoa shattered the air with a blast heard 4,800 kilometers away. A tsunami over 30 meters high devastated Indonesia's shores. The climate cooled. Sunsets turned blood red around the world. In 2011, the Tohoku earthquake magnitude 9.0 triggered a tsunami that overwhelmed Japan's coastline and caused the Fukushima nuclear meltdown. The quake was so powerful, it tilted Earth's axis. In 2004, a megathrust quake in the Sunda Trench generated a tsunami that raced across the Indian Ocean, killing more than 230,000 people. And in 2025, a magnitude 7.6 quake struck the Philippines. In the weeks that followed, seismic activity flared along Indonesia's volcanoes, and across the Pacific, Chile's Villarrica showed signs of awakening. These aren't isolated events. They are whispers, reminders that the Ring of Fire is always watching, always shifting. It doesn't erupt all at once, but it doesn't have to. So how does one eruption influence another? Earth's crust isn't uniform. It's full of cracks, stress zones, and magma pathways. When one area releases tension, it may shift stress elsewhere. But here's the catch: volcanoes don't share one pipe. Each has its own system, but they are tied together by tectonic pressure. For example, the 1960 Chile earthquake, the strongest ever recorded, increased pressure along the Peru-Chile Trench, where several quakes followed. The Earth doesn't explode all at once, but it does react. What's beneath the ring of fire? Plenty, and not all of it is lava. Magma chambers, pressurized molten rock waiting to escape. Depths vary from 5 to 50 plus kilometers. Some chambers stretch for hundreds of kilometers underground. Minerals and metals. Subduction zones concentrate gold, copper, zinc, and rare earths. Many volcanic arcs are mining hotspots. Methane hydrates, trapped under pressure beneath the seafloor, can destabilize during eruptions or quakes, potential for explosive underwater landslides. Today, over 800 million people live along the Ring of Fire. Cities like San Francisco, Tokyo, Santiago, and Manila are all built on tectonic roulette tables. What are we doing to prepare? Seismic monitoring. Thousands of sensors track tremors in real-time GPS plate mapping. Satellites measure movement to the millimeter deep Earth imaging. AI used to model pressure buildup zones, tsunami warning systems designed to save minutes that mean everything, but technology can only do so much. Early warnings might give us hours, but not weeks. Many scientists believe we're currently in a quiet period geologically speaking, but history shows that quiet periods don't last forever. Between 1250 and 1850, during the Little Ice Age, clusters of major volcanic eruptions were recorded, including Iceland's Laki, Indonesia's Tambora, and others. And new models suggest that stress is building along several subduction zones, including Cascade Subduction Zone, Pacific Northwest USA, Nankai Trough, Japan, Hikurangi Margin, New Zealand. Could multiple zones rupture in close succession? That's the concern, not one eruption, but a global cascade. The Ring of Fire is not just a geological feature. It is a force of nature shaping landscapes, fueling evolution, and reminding us that Earth is still alive. And we, the passengers, are here on borrowed time. We can't stop tectonic plates, but we can understand them. We can prepare. And above all, we can listen when the Earth speaks. Because when the Ring of Fire awakens, it won't whisper. Thanks for watching.